Hey guys, let's go ahead and go over quiz number 11. This was given to you guys on March 17th before spring break. Question number 1, how are the graphs of a function, let me highlight that, a function and then its inverse related. So A, the graphs of the are symmetric about the y-axis. So that was the phrase I had, evenly. And that's if you had something like x to the second power and it was symmetrical about here on the y-axis. Okay, that would have been that scenario, but that one's talking about symmetry. So it's not that one. Okay, in blue here, B, the graphs are symmetric about the x-axis. This one is if your a value is a negative. So again, if the parent function is something like this, right? Quadratic, super easy, y equals x to the second, and then if you make this one negative in front, the graph will just reflect it over the x-axis as a mirror. But that's not what inverse means. And let's do D. The graphs are identical basically means that this would be something kind of, we call it infinite amount of solutions. Infinite solutions. And basically what the graph would be is if I had this graph here in yellow, and then the same graph as I go over the yellow and red, every time they're touching is a solution. So there's infinitely amount of dots, so that would be that case identical, but it's not that one either. The answer is C. And this one is symmetrical about the x-axis. So let's again, parent function. Remember we kind of talked about this idea where if you rotate it 90 degrees or counterclockwise, then your graph would be looks like this. And then if you flip it over the y-axis, then your graph would look like this one here. And I didn't do a great job. Let's see if we can do that one again. Better feels like this. And the reason why is that y equals x is this line that I'm drawing right here. It's just a linear, it's a mirror identity, and so the black and the green are essentially inverses. All right, number 2. What is the exponential form of this problem? But the main idea for exponential here is what you see in here is we see this radical sign, and basically we need to get rid of it. So no or not a radical function problem. We have to get rid of that. Okay, so I'm first going to put this x here in red, and its exponent inside the radical sign is a 3, and that becomes your numerator. And then let me go ahead and grab another color here. The purple, this is our root. That becomes your denominator. So my fraction there is x to the 3/7, which would be choice A. Okay. B is wrong. A lot of students on B, they like to think of this one as, they think they mix up the numerator and denominator. C and D have this idea of the negative. And let me show you what a negative means. X to the -1, if you had to simplify that, basically means this will go all the way down. And the negative sign, the yellow, actually goes away. And so x to the -1 is the same thing as 1 over x. So it's not C or D. Okay? Number 3, your favorite word problems. Don't be scared of them. The relationship between the length of a pendulum. Let's say you have a piece of string and a pendulum is something on a string, and it swings this way, and then gravity pulls it back that way. Okay, so like a coin tied to a piece of string. The relationship between the length of the pendulum and its period, t in seconds, is modeled by the equation t equals 2 pi radical L over 32 to the nearest root, which is the length of the pendulum with a period of 8 seconds. I don't know, they gave us this formula, so I'm just going to go ahead and copy down that formula. Okay, so this part says to the nearest root, what is the length of the pendulum? Well, length, they told us up here, is L. So basically what we are trying to figure out is L. So we're basically solving for this variable. The answer is going to be L equals. Does that make sense? Okay, so the T represents, what does it tell us? The period. That's what it's telling us. And here the period is 8 seconds. So I can say that T equals 8. T equals 8. Okay? And I can just fill out the rest of this. And basically what I need to do here is just, I need to solve for L. So solving, remember, PEMDAS, but solving goes this way. So I'm going to do the addition subtraction, which there is none. Now I'm going to do multiplication division, which I see here. I'm going to divide both sides by 2 pi. 2 divided by 2 is 1. Pi divided by pi is 1, so they've canceled. 8 divided by 2 is 4. So that is 4 times 2 over 2 pi. Those are equal. And what I'm doing here is just canceling this 2. So essentially that left side is really 4 over pi equals the square root of L divided by 32. Okay, next I need to get rid of that radical sign or exponent. So what we've been learning is that the root in this problem is a 2. Right? If it doesn't have one, you need to put one there. So this 2 and this 2 and the radical sign cancel. Okay, but if I square the right side, or what I did in black there, I'm going to have to do this on both sides here. Okay, this will, let's move this. This will give me L divided by 32 equals, now I can distribute this, this is going to be 4 squared over pi squared. So 16 over pi squared. And then if I, now we're continuing opposite of divisions, multiplication, so I'm going to multiply both sides by 32. Notice how that 32, I make it a fraction, is in the numerator, so 32 times 16 gives me 512. So I have 512 over pi squared equals the length. Okay, here's my calculator ready equation. I'm not using my calculator variance. Let me show you guys. Graph and Calc 83 right here. And I'm going to put the numerator, 512, in parentheses, division. And the pi button is in the, it's different in various calculators. Mine's in the right side above the division in yellow, so I'm going to have to press second. That one. And then squared is to top left of the 7. Okay, and it gives me 51.876. 51. And it tells me to round this answer to the nearest foot. So anything that's closest, that would be choice C, 52 feet. Okay? Okay, number 4. Which is the graph of the inverse? I'm gonna underline that one. Inverse of the function c of x equals x cubed. Okay, so remember the inverse, graphically, we had some steps. What were the steps? I don't know what we called it. We called it the trick. And you basically need to rotate it 90 degrees counterclockwise. And counterclockwise is another way of saying left. So if you take this graph, do it again over here. Here's my graph. And we're going to rotate it this way, left. And so my new graph is going to be over here. Okay, and then the next one is we need to reflect over the y-axis, which means we need to go across. So if you remember those reference points, they were like this one, right? They're going to go across the y-axis here. So that means those points are going to be something like here, here, and here, and here, and here. So the black is our correct graph, okay? It's not A, because A is actually the graph of x cubed. But we're looking for the inverse, okay? So this is just the parent. We're looking for the child function. B, if you look what we did for B, this one works, right? That's the graph of our black one here. So that one matches. Let's look at C. C was only, what is C? C looks like they reflected it over the y-axis. So let's say C of x is x cubed. Well, this graph looks like some other graph. We'll call it d of x. But remember, if you have the negative in the inside, it reflects it over the y-axis. So a reflection over the y-axis is the negative, because that would be kind of like b equals -1. So that's not this one, because we're looking for the inverse, not any kind of transformation. And then over here for D, that looks right, but they this is wrong. They forgot to they only y. They applied first part of the trick, which is just rotating it 90 degrees counterclockwise. Okay. What's the fix? They need to now reflect over, let's call that fix. How do you fix this graph? Reflect over the y-axis. So when I do multiple choice questions, I'm always going to do the problem first and then apply it to all the choices we have. So it's not this one, so our answer is going to be this graph. Okay? All right, number 5. Which of these functions are invertible? Another word for invertible is just which ones can you take the inverse? Select all that apply. Okay, so if you haven't remembered the trick, this was in our skills practice about power functions. Power functions, as a quick review, are like x to the first and x to the second. Now, I picked these because these are the easiest power functions you know. Okay, so this number here is an even power function. And that graph, let's just put all the characteristics out, that looks like this. Are we okay so far? And then x to the first looks like this. Okay, this would be an odd power function. Okay, now we tested these by using something. The vertical line test helps us determine if it was a function. So does the left one, the blue, pass the vertical line test? Yes, it does. And does the even pass the vertical line test? Yes, it does, because you can draw a line here and it goes through. Does that make sense? Draw a line through here, only goes through one point. Okay, the other one is called the horizontal line test. The horizontal line test will test if you can take the inverse. Right? So right here, it goes through once, that passes. Okay. This one, though, that one fails because it's going through 2 points. 1 point pass, 2 points or more fails. Okay. So this one passes, but this one fails. Okay, what am I trying to say here? And it's basically, I'm trying to say is that anything that is an odd power function will pass, and it can take the inverse. So anything that is an odd. So you're just looking up here, and you're looking for odds. So odds in our case would be A, B, and D. Okay. Remember, this is an even, and this one would fail the horizontal line test. That would have been that green graph to the far right. Okay. So quick ways of just not memorizing it. Number 6. Which type of transformations transform the graph of f of x equals the cube root x into the graph of f prime? So this is just another name. You can call it, I don't know. Let's just say you call it g of x. Let's just write it out here. Which types of transformations transform this graph to that graph? Okay. All right, so what I'm going to do is write out the parent function. And I want to notice all the transformations that we have. So remember, it is a radical bx minus c plus d. There is no number in front here, from here to there. There's nothing, so it's not a. Okay. There's nothing to the left of this x here, so there's no b. Okay. There is something to the right here. Let's do that in red. Okay. Of the x inside the radical sign, so that means that c is equal to 2. Okay. And then the last one would be anything outside of the radical to the right. There is nothing, so there's no d value. So I have c equals 2, and this means you're going to go towards the right. Okay, so let's graph that really quickly so you can give an idea. Here is the cube root. Remember those reference points? You can just put in numbers like the cube root of 1 is 1. That's right here. And then the cube root of 8 is 3. So that would be 8, 3 right there. And so this is my graph. Trying to make those reference points distinct. And basically what that one is, you're just moving these points to the right too. Something like this. And this is what your graph would look like. Okay, that's the transformation. Okay, so our c value is something called a horizontal shift. This is your c value. So that is our answer. Okay, why are these other ones wrong? A vertical stretch is a value that is greater than 1, but we had none. So none. Oops. None. Okay, so vertical compression would be an a value that's less than 1, but there was none or no a value. So it can't be a, can't be b, and then the last one, a vertical shift would have been a d value on the outside in green there with a circle over here on the far right over here, but we had none. So the answer is just 6D. Okay, last question, number 7. which is the result of extracting all possible roots from the radical. Okay, so there's one method here. This is rational, how to do this problem with rational exponents. Okay, so let's divide this in half and show you this method here, how to do that. And basically what it is that you just change them all into fractions. So there's a 2 up here. 20 r to the 5th and s to the 12th. Okay. Remember, let's say we do this in red. Okay. So you have 20 here to the first power, but a denominator of 2. You have r to the 5th here, but in the root there is 2. And then you have s to the 12th, and you divide it by 2, because the denominator is from this root there. Okay, so here you can just simplify, and what you really want to do is you kind of want to make these by 2's. Okay, so this is what I'm talking about. You can do just in black here. 20 is really 4 times 5, and you can do this 1/2 here. And this r, you can do the same thing. You can do something like this. You can do 4 over 2 and r to the 1/2, because you're just adding the numerators. 4 plus 1 gives you 5 halves. And then the s, which is kind of nice because 12 divided by 2 is 6, and that's what I want. Okay, over here, this one is going to distribute the 1/2. So the square root of 4 becomes this one. Let's do 4 to the 1/2 is just 2. 5 to the 1/2 cannot be simplified. Okay, so that one stays. So if I put it back out, you can do this. Okay, that's the 5. R, 4 divided by 2 is 2, so you would just have r squared. Put that in blue. So we've done this one, this one, this one. Okay, r to the 1/2. The 1/2 is not divisible, right? So that r stays inside. That's this one right there. And then r to the 6, we already did the division, so that's already, that should be an s. S to the 6th power. Okay, so that is our answer. Oh, too big. Let's go back. No. Oh, that's that one. Pink. Oh, not bright enough. Okay, so I also want to talk about, we had something called, an abbreviation called, if you guys remember, EVO. And what EVO stands for is even root. That's what the E is. V means variable. And then the O stands for odd, and it is on the outside. Okay, so let's go through these. It is an even. Okay, we're talking about variables. So these here on the outside. Okay, so I have an even root, the 2, the variables, which are r and s, and on the outside are any of those odd. Because none of those are odd, the 2 and the 6 are evens, this one does not apply. Okay, so I don't have to put it in my absolute value. Okay, so this one is one way of solving rational exponents. Let me show you guys one other way. You can just simplify this by the radical. Simplify by radicals. Okay, that's a scary sign of this neighborhood, and inside the house is 20, which is, I'm going to make it 4 times 5, and r to the 5th is r times r times r times r times r. There's 5 of them, and then there's 12 s's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if you have a pair, which I can make the 4, 2 times 2. And you'll notice that the relationship here is all multiplication. So if there's a pair, they can come out. There's a pair. That becomes 1, 2, right? So the story I tell is that I used to teach in an area that's really scary. Outside your house, you need 2 people that are exactly the same age in order to come outside the house. But the place was so scary, like you don't want to get stabbed. You're basically hugging each other, you're so close, when you look at them from afar, it's just one number. I know, that was a really scary place. So that becomes an R. And the relationship outside is multiplication. Let's just use greens. There's another pair. Do you see how that one R, though, doesn't have a pair? Can't come out. The 5 couldn't come out. Let's do the S's. There's a pair. Only one of them. Okay. They looks like one, just one person. 3, 4, 5, 6. Okay? And then you go back and just see who can come out. That was the 5 and that was the R. And you just clean this up. You would get 2r squared, s to the 6, and then you would apply evo. And the best answer is C. So that was quiz corrections for quiz number 11. We'll see you guys. Bye-bye.